Hi everyone, welcome to WeeklyWed. WeeklyWed is the go-to session every Wednesday happening here virtually. And WeeklyWed talks about speakers from AI, AV, IoT. Today we are here to host WeeklyWed to none other than me. So I am the speaker here. I'll be talking about RAG today, and Yashwant will be later doing a demo. So, uh, yeah, the YouTube streaming is happening and the summary is live. Okay, we are all set to do the weekly vet. And I want to give a brief intro about myself. I am Yashaswini Vishwanath. And I have been working in IT for the last 12 years. And I'm an engineer, coder, researcher, all in one. And I'm pursuing my PhD in machine learning. So, starting off, today's topic is called RAG. Let's dive deep into it. Let me first open the window for RAG. So, I would like to initially have an introduction from all of you here about where you're coming from, what's your name, where you're coming from. Please feel to chat it in the chat box here. We have a very close set of students who are coming here and learners who are coming here. We make it individualized to each learner such that we can take their queries and talk to them. So let us begin. What is RAG? Retrieval Augmented Generation. So retrieval augmented generation, that is the full form of RAG. That by itself tells a lot about it. It is the generation that is augmented by retrieval. In the next 30 minutes, we will deep dive into RAG. RAG is an AI framework for retrieving facts. So what do we mean by facts? Facts are entities that are true, that exist in the real world. Here, I would like to give you an example of hallucinations that we have seen in ChatGPT. Those are not facts. Those are hallucinations. But RAG, it retrieves facts. It does not have a problem with hallucination. External knowledge. How do we talk about RAG? It is the external knowledge database plus LLMs. So we have a database which has all the data related to the RAG, and we have the LLM, large language model, and a combination of these creates RAG. So Suresh, Emanuele, I would like to know, do you have any doubts about RAG? Did you understand what is the basic functionality of RAG?
So you said RAG is retrieval augmentation system, correct?
Yes.
And so it pulls the data and it adds some information. Is it a confirmation system? I'm sorry. Is that what it is? Or it's just how it retrieves the data?
It retrieves the data from the documents that we provide to it. So I will share screen and show how it's done.
Okay.
But I mean, I think the question it will be is if you're getting the data from, where are you getting the data from? So which one is the right, which one is the hallucinated data? So that's, and I guess on certain things you know for sure, because maybe physics-based, but other things may not be as obvious.
So there is a database of knowledge and an LLM. I'm sorry. There is a database of knowledge and an LLM which connects to this, and it retrieves the data augmented by it. So the augmentation comes because of the external knowledge database. We take the data, we take the capabilities of LLM and give the external knowledge database, and that results in RAG. Why do we need RAG? Can any of you tell it? Why do we need RAG? We need RAG because it's most accurate, up-to-date information to give users insight into LLM's generative process. It gives an insight into LLM's generative process. LLMs know how words relate statistically, but not what they mean. This is what causes hallucinations. So can either Suresh or Emanuele tell about hallucinations for us?
So it just makes up without knowing the concepts of what it actually means. Right? I'm not able to think of an example, but if you ask for, I'm thinking if the word means a couple of things, I think it can mean it can pick up. You may be thinking of one thing, but it may be thinking of the other things and generate some text for you based on that. I'm thinking that could be the hallucination. Yeah.
Yes, that is what hallucinations are. The large language models can be inconsistent. They regurgitate random facts from their training data. They sound like they have no data what they are saying. That is what Suresh also mentioned. They sound like they have no idea what they are saying. What are the effects of using RAG? The model has access to the most current facts. So we said that we have a knowledge base that we give to the LLM. So that has the most current facts, and we retrieve from the knowledge store. We retrieve the current facts from the knowledge stores. The reliable facts. Users have access to model sources, ensuring that its claims can be checked and accuracy is ultimately trusted. This is very important because here we see that we need to trust the output that is given by the LLM. We need to trust the responses that we get when we query an LLM. Here I open to the audience to tell me how important trust is for taking charge of the facts or the responses given.
Yes, one small question. So, is the hallucination different from lying outright, correct? Or is it the same in this case? Like, it may say the population of the world is, 5 billion, for instance, based on the old data that it might have had, or maybe the correct population is 8 billion plus. So,
Okay.
Can you clarify if hallucination and misrepresentation of the data are the same or it's different?
Yes, hallucination is misinterpreted data, but the way it is told by the LLM is in a very confident way.
So that is hallucination. Okay.
It tells in a very confident way and also tells in context that makes us feel that it is right.
I see.
So there are 2 points to it, in context, and the second point is the confidence with which it talks.
So it makes you, so
Yes.
it makes you believe that it's telling the right thing, but it's not.
Yes.
Okay, perfect.
It's an hallucination. So models have fewer opportunities to pull information baked into its parameters. This reduces the chances that an LLM will leak sensitive data. The main problem with the privacy of data is that an LLM, which has been trained on this sensitive data, can leak the data. RAGs take care of it. RAG is a solution for hallucination of LLM. I would like to pause here and ask Emanuele what he thinks about hallucinations.
Yeah, I mean, I think it just I think that the LLMs are the way I'm looking at it, just like it, they could be pretty inaccurate because there is no filter, and so having the hallucination is kind of the result. And so being able to put something a little more into context and is really what is really coming out makes sense or not, having a second filter, I think that would be important.
Thank you, Emanuele. That is indeed what hallucinations is what we are talking about. There are other advantages of RAGs. It reduces the need for users to continuously train the model. Say, for instance, your document grows. How do you access the contents of the document by your chatbot? You need to retrain it. The whole LLM needs to be retrained with the new data that has been added. But when we have a RAG, we just augment the data. We just augment the data and we don't need to retrain. Training the model as we have new data, updating a new circumstances as it arises. So I have a question here for Suresh and Emmanuel. What is that one aspect of data and LLMs that is of a problem? Data and LLM over time.
Repeat the question again, Yash. Sorry.
What is the main problem of data and LLM over time?
It remains the same unless you add new information to it, or it goes stale.
That is one way of seeing. The other way of seeing it is, if we have to retrain the LLM, it is expensive. The cost is expensive. If we get new data and we need to retrain the model, the cost is expensive.
Right.
So RAGs do not need retraining of the entire model. We just augment the data which can be retrieved from.
So you incrementally train the model, is that what you're saying? With the new data? Right?
Yeah, here is the difference. Here is the difference. In a RAG system, you're asking the model to respond to a question by browsing through the contents of a book, as opposed to trying to remember facts from memory. This is an analogy.
I mean, are you applying like a filter? So in other words, if you think about in a very simplistic way, you have 10 sets of information, say 10 sentences in your LLM, but in reality you have millions and millions. But then with the RAG, you're gonna say, okay, out of those 10 sentences, those are the rules, and some are correct and some are not correct, and then you're removing the one that are not correct. Is that the principle?
So in a RAG system, we will have the augmentation of the data. We have the augmentation of the data and we retrieve the facts from this augmented data. Instead of trying to remember all the facts and making a big model, this is what we try. Emalia, did I answer your question? Or is it something different?
Yeah, I think that's okay.
Okay, we will go ahead with the slide deck. There are two phases of RAG: retrieval phase and content generation phase. In retrieval phase, the algorithms search for and retrieve snippets of information relevant to the user's prompt or question. This is the retrieval phase. So from the retrieval phase, we get the prompt. So how does it work? We have an augmented prompt. We use the database and we create an augmented prompt. We create an augmented prompt and we feed it to the retrieval. We have the retrieval generation, we have the augmented prompt, and we feed it to the LLM. And the chatbot is ready It is a RAG enhanced chatbot. These are the two slides that I want to go over again. That is, how does it work? Augmented prompt. Augmented prompt, it takes the prompt and adds it to the prompt that was generated here. It takes the prompt and adds it to the generated prompt here. And then we take the augmented prompt and add it to the LLM. See, there is a sequence here. We have the knowledge base, we have the prompt, and then we have the augmented prompt, and then the LLM. This goes as a flow. Here it's very simple. There are 3 key points that you have to remember. The first one is, what is a RAG? RAG is a system. You are asking the model to respond to a question by browsing through the content, as opposed to trying to remember the facts from memory. Okay. The second one is, how do we do the retrieval? The algorithm search for and retrieve snippets of information retrieval relevant to the user's prompt or question. So here we see how it is formed. There is a user prompt that is formed by the retrieval model, and then this augmented prompt is given to the LLM. There is a flow here, and this flow is generally handled by a lang chain. And this is how we can create a chatbot. So, Suresh and Emanuele, do you have any doubts about, now we are open to discussion about RAGs. Do you have any doubts? The 3 key points. What is a RAG? How do we come up with the augmented prompt? And how do we give it to the LLM? These are the 3 key takeaways of today's talk. And generally, lang chain is used to glue all this together.
Got it, Yash. No questions. No questions from my side.
Yeah, that's good. Thank you.
Okay. Now we will have a demo by Yash. He'll be showing a lot of content around how to create it, how he has created the demo. So let us wait for him to come on board. By then I will have an informal discussion with you guys about what do you think about bringing together a chatbot through LLMs. What are the entities that are needed?
So definitely an LLM, and also something to fine tune with what you want the chatbot to respond to, I guess. Context, correct?
Yes. So we need an LLM.
Yeah.
And we need a database where we store our data, query our data, and we need a glue which can put all these things together.
Yeah, understood. That's true.
There are various LLMs. Some are open source, some are not. Some are being hosted by Hugging Face. And some of them we can give the API calls directly, like OpenAI. So Yashwant is here, and I would like to make him the host, or let me see if multiple participants can share it. Okay. Yashwant, are you ready?
A moment, just a moment. I'm ready. Just a moment.
So Emmanuel and Suresh, have you tried building a chatbot using RAG at any point of time as an experiment or somewhere at a hackathon? We would like to get your learnings, your first-hand experience.
I built it with the IBM language dialogue or whatever it is some time ago.
Dialogflow.
Dialogflow, Google's Dialogflow and IBM's. I don't know what it's called as now, but yeah, definitely built it at that point of time. And also, I think more recently, OpenAI had introduced something to create chatbots. So I was looking at it online, but I haven't created one yet.
Okay. Maybe today's takeaway will be that we'll all create chatbots.
Yeah, that's nice.
So RAG is very important to create chatbots. To put it in a nutshell, RAG will have the data and it will retrieve, the RAG system will retrieve facts from that data that is there. So we have data like VectorDB, ChromaDB, and all those DBs, which has the vectors, and this RAG system, it retrieves the fact from that. In the first stage, it seems tough, but then as we start working with it, we come to know that there are 3 or 4 pieces and a glue for these 3 or 4 pieces. So Yashwant, we are here. Are you ready? Okay, let us know when you're ready. We will be discussing.
Yeah. So, Yash, maybe by the time Yashwant is getting ready, I had a question. So, you take your data and build a vector database with the data first,
Yes.
and then use the vector data. Okay, go ahead.
Yes, you need to use a vector database. So basically, we need a store for the embeddings.
Right. Okay. And then
We see it, the way an LLM sees data is through embeddings.
Okay.
So Sudha has taught in many lessons about embeddings,
That's right.
tokenizers, and so we have embeddings. We need to store these embeddings in a DB. We should be able to retrieve these embeddings and perform the query search. See, the main point here is an LLM, just an LLM can hallucinate. It can tell something imaginary on the fly, whereas a RAG, it can only retrieve from the documents that you have given or the websites that you have given. That is the embeddings that you have created. So it can only give you facts. If you have given facts, it can throw back facts at you.
Yeah, I'm back. Sorry for the disturbance. There is a network issue. That's why I can't hear you.
Okay, can you hear us now?
Yeah, it's perfectly all right. Yeah. Hi, Suresh. Hi, Emmanuel. Hope you have a nice day.
Definitely, Yash. Thank you.
Yeah.
So I will hand over to Vanama Yashwant. So I will quickly brief about Vanama Yashwant. Vanama Yashwant is an engineer here in the Silicon Valley of India in Bangalore, and he is the NLP expert and an expert in LLMs too. Today he is here to discuss about RAGs. So Vanama Yashwant will show a demo about RAGs, and then we will have an ensuing discussion. All of you are encouraged to ask questions and have a discussion. Over to you, Vanama.
Thank you, Yashashwini. Yeah, as Yashashwini said, my name is Vanama Yashwant. You can call me Yashwant. I've been hearing your questions in the YouTube discussion. So it will be pleased if you ask any questions you have before we start from the base. So I would like to answer if any doubt that you have before experiments about the RAG or the development of RAG. So any questions I'm open to answer.
Vanama, so there's no data limit for building the database first, correct? It needs to be the LLMs are large language models, typically like billion parameters and stuff like that.
Yeah.
But for the RAG database, there is can I just feed it one document? I mean, I know it's silly, but or is there any data limit on that? I'm not sure.
No. To be frank, there is no data limit as such, but your program or the bot that you have created might perform under because of the insufficient of data. But there is no such thing that you have to keep only half document or one document or 100 documents. But if that particular LLM might have the data that is related to the document that you have provided, for example, and you have given the access to the history equals to true for in the code, then it might go to the context that you are trying to ask, and it might give its own answer. But the temperature should be at most the high. See, I will say you two things here. First of all, I hope you all heard what is meant by temperature, right? That you are giving the skill to make sure that it becomes more and more creative. I hope you know that.
With the higher temperature, correct? With the higher temperature, it's more accurate, correct?
Yeah, no. With higher temperature, you are giving more intelligence to that particular bot to go out of the context from whatever you need to know. It will give whatever it needs. It doesn't make sense. That question that you asked is related to that answer.
So it may be more hallucinating, correct? It may be more hallucinating.
We can't say it more hallucinated. For example, let's take our telecom systems. Okay, so there is a company A, B, C. So you have the data only related to A, but when you ask the question related to B, but your temperature is at 0, then it won't answer your question. It says I don't know. But when the temperature is beyond 7 or 8, it tries to answer you because it thinks it's over knowledge than what you feed it to it. So when you increase the temperature to a certain level, it won't hallucinate, but it will give the out of context answers, which doesn't make sense at that point.
Okay. Makes sense. Perfect.
Yeah. Any questions other than this?
One more question, Yash. So the documents are in a particular format before you feed it into the data set, or do you need to massage the data? Is it like a plain text, or is it like a web pages, or I guess maybe there's a transforming protocol that you need to do something, correct? Okay, fine.
True. So the answer is now the RAG can support multiple formats of data. It can be your MD, it can be your PDFs, it can be anything at the data, but it doesn't matter that it is only one data. It can be web URLs, XMLs, anything.
One more question I have is, sorry, last question. One more question I have
no
is...
problem, you can ask us.
Yeah, one more question I have is if you're feeding the FAQ kind of a thing into the database. So for one question, this is the answer. For another question, this is the answer. So how do you, tell the LLM that, it is not just one big chunk of all things, but, a specific answer for each of those questions?
Okay,
Do
so yeah,
Go ahead.
for example, if you go with FAQs, then with respect to, let's take an example of an e-commerce site like Amazon or Flipkart, then the FAQs might be like, what is the policy of refund or something like that. So at the time, it needs to understand the complete scenario of what is happening. So the data that you are feeding must be the context that is related to that whole product and all the policies you have. Then it won't mind whatever FAQs you ask. It will be definitely answering you. And the temperature should always, it depends upon the temperature also in the code. So you should be always between 0 to 0.3, as it's the best standards to get the exact answer that is only related to your particular organization or anything, to not to go outside of its organization. Is it it is answering your question, or is it some extended you want to add?
I think while you show the demo, maybe I'll learn a little bit more. I'm more curious about question and answer. For question
Yeah,
A,
sure.
answer is A dash. For question B, the
Okay,
answer is
so
B dash. But I want to know
so
how you
yeah,
represent that in the database. That's all. But I'll
so
learn on it.
so yeah, you
So,
let's take an
yeah.
example. So you are a person, okay? So let's imagine ChatGPT or any LLM is also a person, okay? So when you are feeding to it, you are trying to make the embeddings or the vectors to, if you talk in the beyond the mathematics, then it is making the similarities between the questions you ask and the answers it is understood. Then whatever type question you asked, it will make sure that it responds from that particular data that you already fed to it.
Right.
So
Right.
I
Okay.
will show you a demo also, so you will be more
Perfect.
clear.
Perfect.
Um,
Perfect.
yeah. Any other questions or?
Go ahead, Yashwant. Go ahead with the demo now. You
Okay,
have
sure.
20 minutes.
Yeah.
So
Is my
I'll
is my
give,
screen sharing?
I have given you access.
I can
Okay.
see it.
Okay.
Are you able to see it? Yes, I'm not able to see it.
No, even I'm not able to see it.
Is it now clear?
Yeah.
Yes.
Okay. So as we are discussing, so it's how to build a RAG. So let me go with the three different types that we have in initially. So I don't want to stick you people with only one solution that we have, that only one framework you people thinks. But there is three frameworks. That is, one is LangChain, which is also an open source, and Llama Index, which is also an open source, and Semantic Kernel. It is also open source but backed by Microsoft. So if you see in this LangChain, we use this for general purposes and other purposes, but Llama Index can't be used for our general purposes like question and answers and etc. And even semantic kernels also can't be used for our general, like if you want to use your customized, other than the like you want to change something inside that bot, you can't change that, but there are slight specifications for that to do inside this only. But when you come to LangChain, it has more capabilities to customize yourself, so it is there. And you can in semantic search like Google searches, so it has limited variables inside it, that LangChain, but it's very good but limited. But Llama Index has multiple such semantics, such as like you can use Yahoo's and Bing's also, but here you can't get it in the LangChain. And it is conversational AI, so we can talk to each other like, as I said, it can be customizable, but in Llama Index we can't, and semantic it can be. So there are some other important features like it can be scalable or not, or is it easy to use or not. So basically, LangChain is very easy to use. Once if you understood the thing that you want to try to make it, it is very very useful. But when it comes to the semantic search, there is one disadvantage inside it. That is the only disadvantage we see inside the LangChain or Llama Index. And the steps that generally we follow is that first one is data preparation that we can you people see the slide?
Yeah, I can see it. Yes.
So first one is data preparation, and second one is embeddings. So how we create the embeddings and etc. And third one is retriever. So how you retrieve the information from that embeddings is the fourth thing. And this rack can be a generator also, so it can produce the words that are capable for it, and it can be integrated with different types of your entities like WhatsApp. It can be integrated, and Telegram it can be integrated, and etc. And it can be fine tuned also on different. Uh, it can be fine tuned, but people generally won't fine tune on because of more. It is more expensive than general. So this is how it generally goes, and I'll show it in a flow diagram. So, for example, if you can see this, I hope you people can see it.
Yeah.
It's visible, right? Is the words visible? Is it clear? No?
Yeah, yes, I can see the words.
Yes,
Yes.
yes.
Yeah. So first one is document loader. You have multiple document loaders inside the LangChain. It can be URLs. It can be uh, data storages. Uh, it can be WhatsApp. It can be PDF. It can be CSV. It can be directories. Anything. You can do multiple things inside it. Once you got the documents, you can't feed complete at a time to an LLM. So we need to split that into different either it into a sentence wise or into a word wise, so it is more accurate in that times. So when it is sentenced, so that can understand the context beyond the sentence and after the sentence. Once the sentence is completed, or the before the sentence can be also understood when you are splitting the document into sentence wise. When it is word wise, it mostly like an our traditional LSTMs or by LSTMs, like it will only provide you with only one word, that is assuming that high efficiency inside it. Once you got that words, you convert that into vector stores, so you can store them using any vectorization process. We generally go with two different embedding methods. That is, one is OpenAI's embeddings method, and one more is Hugging Face embedding method. You can have multiple, but people prefer it. And the third one is, once you go to this is so once you went to that storage department, there is a space where you create embeddings and you kept it there. That is our vector stores. Once you go to that vector stores, a person queried on your particular vector store, then what it does is it will go to each and every relevant document that is related to this particular query, and this query will be also embedded and it will be sent to this. And once you got, it will go to the prompt, and it will say that okay, I need to do uh, conversation, or I need to do retriever, or I need to be act as a bot, or I need to act as uh, an officer, something like that. And you keep this prompt as a prompt, and then you have in the background as the ChatGPT or any LLM, and it will provide the base for the root, and then it will take that output that is came from the retriever and generate the answer for you. So is this flowchart is or understandable, or something I need to make sure to understand?
Good to
Any
go.
questions
Good
on?
to go.
Yeah, cool.
Good to go, Yashwant. You can move
Yeah,
ahead and show us what you have.
just a moment. If you can see my screen, I have came with uh, this collab notebook. So these are the important libraries that you need to install, and these are predefined for the objective that we need to go. Any objective you go, these are the predefined libraries that we need to install. One is LangChain, one is OpenAI, which connects, and Tick token. It is the most important one, and this is Selenium, and unstructured is for to get unstructured data like web URLs, to get data from web URLs and etc. And Fayaz is an place, is a retriever place where you save this all the embeddings that you got and in the local systems, and you saved it. But when you go to the production level, this is not required. You can go with either Apache Cassandra or MongoDB. So we can do there. So once we got this, and I will explain you what is tick token. Tick token basically makes the words to be a chunk size. Chunks is nothing but a group of words, and that chunks will be divided into words or sentences. So it will make sure that sentences or words are divided uh, according to the standards of embeddings that are like either it's OpenAI embeddings or is it with the Hugging Face embeddings, but it will make sure that that is related to this particular embedding method. So
Is
that
it
is why
a
we use it.
tokenizer?
We can say it as a tokenizer, but mostly an embedding tokenizer. It has a special standard in tokenizer. Tokenizer is a limited form where it is related to that particular architecture, but here tick token doesn't make with architecture. It depends upon how a vector will learn or a DB will learn. So when you went with Fayaz has its own standard of storing the data. So tick token will make sure that storing and that structure is related to Fayaz and OpenAI or Fayaz and Hugging Face. So that is why it is a step more than tokenizer.
Is Fayas a vector database?
Yeah, Fayaz is
Yeah,
a database.
it's a vector database, correct?
Yeah, vector database.
Okay. And also,
have-
once you do this pip install, you don't have to have internet connection, correct? Because I know you're doing the OpenAI. Does it bring the whole OpenAI model into your system?
No. It needs internet because we are connecting it with our OpenAI ChatGPT.
Okay, perfect. Go ahead, please.
So this is how we can load our any type of our websites. So I basically took OpenAI's website only to make sure that you people understood that link. If I go to this link, I will be redirected to this our OpenAI website or a blog that is from Vinuka. So it is also an LLM. I actually love this LLM. So it's very good LLM, and it makes very good open source chatbot that is impressed with GPTs. So I like this. Just a moment. Yeah. So once any type of URL you like to keep, it is open for that. And once you got the data, so here the part is started. So how to build a rack will be started here. So once you gather the data, now you need to load that data into a particular way. So that will be also done by the LangChain itself. So once you initiated the LangChain, uh, the document, then you get there is a something called unstructured URL loader. So basically, what this unstructured URL loader is, so URLs are basically unstructured. We can't define whether it is stable or something. So unstructured loader will take care of that particular thing in order to make sure that it is in the correct format, and it will bring all the data into a variable that is loading here. And all the URLs, you can keep here multiple URLs, not only one. You can keep hundreds, thousands of URLs, and make sure that it will make sure that it will learn all the data. So you can keep a for loop and keep all your documents, I mean URLs, in a private documenter, and you can keep it here also. So it is basically very private. So you no need to worry about whether ChatGPT will learn it or not. So so it will learn. So once you got the data, so as I said, I am doing here character text splitter. That means based on the data I have, I can't do. I want the words to be connected with each other. I don't want with respect to sentence. So I generally took the text splitter with the character, not with the text splitter. I mean, sorry, sentence splitter. So I want that connection between the words to be specific. So I took character text splitter. I want you people to play with here. You can play with sentence text splitter and paragraph also currently. So once you got it, I want you people to play here also at chunk size. So once you have a different types of chunk size, so what chunk size is nothing but you have a large amount of data. Once you have that large amount of data, you can't feed that complete into a single document. So we divide the chunks, and then we do a overlap so that it will learn all the data. Then we just need to initialize our open API key here. And after it, you people might have this, okay, we divided this data. Now what? How will a ChatGPT will learn the data from us? So that's where this play comes. That is OpenAI's embeddings. So it's basically that uh, embeddings are created by the OpenAIs to its standards. So we can use these embeddings and create in a such a way that that model will learn, and I mean our LLMs can understand what the vectors and the target is between them. So once it's created, the vector stocks are created, and we store them inside the FIAS. So once we store that FIAS, we can just load that into a DB and create a chain that is called retriever chain here. So what this generally retriever QA chain do is, it will go into complete retriever, I mean your embeddings database, and then it will learn it, and it will understand that particular question that what you are trying to send it. So once that retriever QA has learned the all the system, I mean all the data that you have sent, then we can play around the retriever QA asking it questions. So what generally here in the retriever QA happens is there is a the data. So once that data is there, so it will be in a way of numerical. So what our QA retriever QA is goes is, it will go to the particular relevant data that you ask, like Google search, and it will do that retrieval and bring it back to you, so that you only get the data that is only required for you, not other than that. So, and here I kept a memory also. So it will understand the previous steps and learn from the chat. So it will become a conversation between the people, not like it gives as a Google search. So there you can keep your conversational memory, where it will understand from its conversations like a chat GPT, like the previous question or top question, and then you can go to the retriever and ask the questions. So this is how it runs actually. So you can ask me the questions. Hello. Yeah. Hello. Can you hear me?
Yes, we can hear you.
Yeah.
So, Vanama,
Yeah.
let us, uh, let us ask Emmanuel or Suresh if they have any questions. So you're done with the demo with the part?
Yeah, it is from my end.
Okay. Emanuele, do you have any questions for Vanama?
Okay. Thank you.
Okay. Thank you, Vanama. Thank you for coming here and giving us a demo. And from WeeklyWed side, thanks for everybody for coming up here and everybody who is there on YouTube and LinkedIn. Thank you. We'll be closing the live stream.